Hello, in this video we will see stack implementation using linked list. Within that we will see what is stack, what are the different operations can be performed onto the stack, and as well as we will see how we can implement those stack operations in the C language. These two are the real life examples of the stack. This is a stack of chair. If I want to add a new chair, I will add onto the top of this stack. If I want to remove the chair, then top chair going to be removed easily. Same will be applicable for this stack of CDs as well. So what is the meaning of the stack? If I want to delete any element, top element going to be deleted. If I want to add the element will be added onto the top of the stack. It means stack follows last in first out order. Now in this video we will see how we can implement stack using linked list. Why we are using the linked list? Because it is, you can say, it allows the dynamic size, that as needed I will allocate the size for the node and I can able to store the data. It means there is a no limit about how many elements I can store into the stack. So if there is a case where I am not aware about what is the size of the stack in advance, that time you can use the linked list representation of the stack. So how can I represent stack using linked list? In case of the linked list, stack is a collection of such a type of nodes in which each node has a two part. One is a data part and second part is a link, which will link to the, or which stores the address of the another element. Stack is a collection of nodes and each node has a two parts, data and link. So how can I declare such a type of structure in the C language? This is a way to declare the structure. First write down struct is a keyword. After that give name for your structure. Node is a name of the structure. Within that integer data. Here you can use any another data type. For the simplicity I have used the integer data type for the data part. After that, as I said, this link stores the address of another node. So because of that you have to declare the link pointer, and as it stores the address of another node, data type will be struct node. Now next thing is we have to declare one top pointer which keep track about the top element of the stack. So data type of the top will be struct node, as this is a pointer. So this is a way to declare the pointer into the stack. Initially your stack will be empty. So we have to set top to the null. It means it is not pointing to any element right now. Now next we will see how can I add the new element into the stack, that is a push operation of the stack. To add the new element you have to follow these three steps. First is a create node, then link node, and last update the top of the stack. So we will start with the step number 1, that is a create node. Within that, first of all you have to allocate the memory. So as you are using the linked list representation of the stack, so it's your responsibility to allocate the memory. After that, whatever the data you want to store that data into the newly created node. So we will see how we can implement these two steps in the C language. Here I have written one C language program. Within that, push is a one function which do not take any argument, as well as it is not returning any value. Within this function we have declared one new node pointer which will point to the newly allocated memory. You can give any name for instead of new node, you can use any name here. After that, with the help of malloc, you can allocate the size. Here we have written size of struct node. What is the meaning of this? Whatever size required for the new node, allocate that much size with the help of malloc function. Now malloc returns the void pointer, so we have to convert that pointer into the struct node pointer. So because of that we have written this line here. Now this new node is a pointer which is pointing to the newly allocated memory. Now it will created new node which has a two parts, data and link part. Now our next step is you have to set the data and next part or link part. So here with the help of printf, this message will be printed onto the screen. then whatever the data entered by user, that going to be stored into the data part of the new node. As new node has a two parts, data and link, so with the help of this points to operator, we are fetching only data part of the new node. Means new node points to data. So whatever the value entered by user, store that into the data part of the new node. After that, we will set the link part of the new node. So we will write down here new node points to link is equal to null. It means store the null value into the link part. Next step is a link node. Under this, we have to attach this newly created node onto the top of the stack. And after that, accordingly, we will update the top of the stack. Means newly created node will become a top of the stack. Now we will see how we can implement these two steps in the C language. Within that, whenever you want to link the node, first of all, you have to check whether stack is empty or not. To check the stack is empty, you have to say that if top is null, that time I will say that my stack is empty. There is no any element in my stack. If there are no any element, that time I will say that newly created node will become a top. So to write this in the C language, I will say that top is equal to new node. It means newly created node will become a top of the stack. Now case number 2 is, consider there are some elements in your stack, then you have to attach that new node onto the top of the stack. Consider this is the case. In that the stack contains two elements. These are the two elements. Now I want to attach this newly created node into this stack. So you have to create this link. Means new node contains two parts. This is the data part and link part. You are going to change the link part of the new node, and in the link part you have to store the address of this previous element. So I want to store the address of this node, and this address is stored into the top. So what I will say that new node link equal to top, means they will create this link which stores the address of this node. Now once you link this newly created node into the stack, next step is you have to update the top. Now this 12 is not remains the top. Who is become a top? This node has to become a top. And what is the name, or who is stores the address of this element? New node. So I will say that new node link equal to top and top equal to new node. So like that, here you are updating the top and here you are attaching the new node to the stack. So this is the way I can add the new element into the stack. Next we will see how can I delete the element from the stack. That is a pop operation of the stack. Under this you have to follow 4 steps. First one is a check empty. Next store data of the top node. Next update top, and last one is a free memory. Let's start with the step number 1, that is a check empty. Whenever you are applying the delete operation, first of all check whether there is any element to delete. If there are any element to delete, then only I will proceed to the step number 1. Otherwise I will stop here only. How can I implement this step number 1 into the C language? Here I have written one code, void pop. This is the name of the function which do not take any argument, as well as it will not return any value. Under this, if top equal to null, it means you are comparing the top value. If it is a null, then I will directly say that stack is empty, there is nothing to delete, and return means return to the calling function. So they will not proceed to the remaining steps. Consider the second case, that is if there are some elements present in your stack. So I will go to the step number 2, that is store the data of the top node into the another variable. Consider stack contains 3 elements, 67, 12 and 24. Whenever you apply the delete operation, 24 going to be deleted. Now who will become a top now? The node which contains the 12 into the data part, this will become a top of your stack. So how can I do that? Under the step number 2, what they said that you have to store this top value into the temporary variable. How can I do that? Again you have to declare one more pointer. The name of that pointer is a temp. You can give any name. So this is a way I can declare the temp pointer. Now you have to set that temp pointer to the topmost element of your stack. So how can I do that? I will say that temp equal to top. So after this instruction, both pointers are pointing to the topmost element of your stack. Once you done that, now you can move the top pointer which will pointing to the node which contains 12 value into the data part. So to move the top pointer, what I will say that how I will get to know address of this node. This address is stored into the link part of this node. So I will write down top equal to top link. So they will move the top pointer to this node. Once you done that, they will only move the top pointer, but temp will still pointing to this node which contains the 24 into the data part. So temp will remain here, top will move to this location. Once you done that, you will just use the last step, that is a free memory. Under this I will write down free in bracket temp. It means whatever the memory allocated for this node, just deallocate that memory. Means they will deallocate the memory which is allocated for this node. So like that you can deallocate the memory, or you can delete the one element from the stack. Next is a display all the elements of the stack. To display all elements, you have to follow the 4 steps. Step number 1 is check empty, second initialize pointer, third check and print, and last one is a move forward. So let's start with the step number 1, check empty. Whenever you want to display any elements, first of all check is there any element to display. It means if stack is empty, I will not go to the step number 2, I will return back to the calling function. Otherwise, I will go to the step number 2. So how can I do this into the C language? Here you will check if top equal to null, means compare the top value. If it is a null, then just print stack is empty and return back to the calling function. Now second case is if stack is not empty, then I will move towards the step number 2. In the step number 2, they said that you have to take one more pointer, that is a temp pointer, which will initialize to the top element of your stack. Means they will point to the top element of your stack. So for this you have to declare one pointer, that is a temp pointer. This is a way to declare the temp pointer. Once you done that, you have to write down in the else part, you have to write down temp equal to top. What is the meaning of this? Where top is pointing, at the same location temp going to be point. So after this instruction, this top and temp both are pointing to the topmost element of your stack. Once you done this, this is a simple message will be printed onto the screen. Once you done this, we will see while temp not equal to null. So here temp is a not null, it is a pointing to some node. So condition is true, it's not null. So we will enter into the while loop. Under the while loop, they have written print the temp points to data. So here as well, temp contains 2 parts, data and link part. So what I will say that in the temp data part, whatever contain into the data part of the temp, just print that value. So they will print the 24, and after that what we have written is move forward, that is the last step. Temp equal to temp points to link. So it means this is not a temp now, just move forward next temp to the next node. So they will point to this node, that is they will point to the node which has a 12 into the data part. Remember that top will remain at the same location, they will pointing to the topmost element of your stack. Now temp will come here at this node. Again temp is a not null, so it means this condition is true, so they will enter into the looping, and after that you have written now temp points to data. Right now they will print the 12 as this contains into the data part of the temp. So 12 will be displayed. After that you said that temp equal to temp points to link. So move to the next element of the stack. So here they will move the temp pointer, temp will come here. Now again you are going to check temp not equal to null. Yes, it's not equal to null as it is a pointing to the one of the node. So after that, this condition is true, so they will enter into the while loop, and you said that temp points to data, means print that data. So they will print the 67. After that, you said that temp equal to temp points to link. It means again move forward. So if temp try to move forward, now in this link part contains null, so temp will become a null in this case. So here when you are trying to check this condition, temp not equal to null, this condition is false. So they will come out of this while loop, and here again there is a closing of the else and closing of the function. So we have finished with the display function. Like that you can print all the elements of the stack. We have seen how can I add the element, delete the element, as well as display all the elements. So we have written the function, but you have to call that function as well. Then only the code which are written under the function going to be executed. So how can I call those function? This is a flowchart. Here first of all I will display the menu, and after that I will ask the user to enter their choice, means whether they want to add the element, delete the element, or they want to check out what are the element present into the stack. So user will enter the choice, and depend upon the choice I will call to the particular function. It means suppose if the choice is 1, then I will add the element. If the choice is 2, then I will delete the element or pop the element. If the choice is 3, then I will display all the elements of the stack. If choice is a 4, then I will come out of the program, that is exit the program. I don't want to proceed. And suppose user has entered any another number, that time I will display the invalid choice. And if I add the element, pop the element, display the element, and suppose user has entered the invalid choice, then I will return back to the display menu. So they will display a menu again, and the user can enter their choice again. Only thing is, if user enter the 4, then I will come out of the program. How we can implement these things into the C language? Here I have written main function. Under this I have used one while loop. Infinite, this is an infinite loop because repeatedly you want to display the menu. So if the user enter the 4, then only I will come out of this my program. They will stop the execution of the program. Otherwise repeatedly they will display the menu to the user. So to achieve this, we have to use the infinite loop. This message will be printed onto the screen. In the second message, we are just to show the menu to the user. Suppose they want to push the element, they have to enter 1. Otherwise, they want to delete the element, enter the 2. So such a type of menu will be displayed to the user. Then next message, enter choice. So this message will be displayed to the user, so that they will enter one value between 1 to 4, and this value going to be scanned into the one variable, that is a ch variable. So we have to declare that variable. Data type will be integer, as they are using the 1, 2, 3, 4 such a type of numbering. Now next is whatever the choice entered by the user, that is stored into the ch variable. So depend upon this value of the ch variable, I will call to the particular function. So for that we have to say that switch on which variable, onto the ch variable. So under this we have to write down all these cases. So what is the case number 1? Case number 1 is push the element. So if I want to push the element, call to the push function. Once you complete the push function, break, means come out of the switch only. After that, if case number 2, call to the break pop function, and after that break, means come out of the switch. Next case number 3, display, break. Case number 4, exit, means user want to come out of the program. So exit 0 is used for this. And after that, if user has entered any number other than 1 to 4, default is invalid choice and break, means come out of the switch. Once you complete the switch, there is a completion of while loop, and while is an infinite looping. So again they will come here at this line, again they will display the menu, ask the choice to the user, and according to choice they will call to the particular function. So when I come out of the program, when I enter the 4, then I will stop the execution of the program. So like that you can write or call all the functions into the C language. Now I will show you how can I execute the program and I can able to add and delete the element from the stack. Next, I will show you the execution of the program. Just now I have explained you all the function. I have written the same code here as well. First of all, you have to include these two libraries. stdlib is required whenever you are using the malloc and exit. So you have to include this both the library files. After that, this is a structure you have declared. Next, set the top is null initially. This is a global variable you have to take. After that, write the code of the push function. Next is write the code of the pop function. After that, write the code of the display function. I have already explained all these codes. After that, write down the main function, and from the main function call all these functions. This code is also explained. Now I will show you the execution of this code. This menu has been displayed: push, pop, display and exit. After that, they are asked me what is your choice. Suppose I have said that I want to display the element and I have entered the 3. Now they will say that stack is empty. It means there is no any element to display. Suppose I said that 2. It means I want to delete the element. Still they will say that stack is empty because there is nothing to delete. Consider I said that I want to add the element. So choice is 1. Now they will ask me the what you want to store into the data part of that node. Consider I said that I want to add the 45. So 45 has been added into the stack, and if you call to the display function, you are able to see that stack elements are 45. Now if I add the one more element, that should be added onto the top of the 45. So again I will call to the push function, and I said that I want to add the 78, and I will call to the display function. If you observe that they have displayed the 45 and 78, so they have added onto the top of the 45. Now next is, suppose I just say that I want to delete the element. In this case 78 has to be deleted first, so I will call to the second pop function. So they have, again I will call to the display function, so I am able to see the changes. So 78 has been deleted successfully, so there is only one element present into the stack, that is a 45. So and if I enter the any another choice 5, they have displayed, that is an invalid choice. And if I want to exit the code, I will enter the 4, so they will come out of my program. So like that you can execute the code. I hope you are able to understand the linked list implementation of the stack. Thanks for watching my video. Thank you.